Hello student, in this class we are going to discuss and proving the given result using properties of determinant. So on the expansion of determinant as 1, 2, 3, 4, 5, 6. There are 6 factors x, y, z into x minus y minus z into z minus x. So we have to use properties based on properties. Okay, so let us start with the introduction of the determinant as delta. Delta is the given determinant x, y, z, x square, y square, z square, x cube, y cube, z cube. So we can take x as a common factor from C1, y as a common factor from C2, similarly z is a common factor from C3. So write taking out x, y, z respectively from C1, C2 and C3. Then delta, you take x, y, z, x, y, z, take all the common factor as a multiple of determinant. Write C1 without common factor x, 1 x, x square. Similarly 1 y, y square and 1 z, z square. So dear student, whenever we reaches any row or any column containing 3 ones, 1 1 1 in rows or 1 1 1 in column, then it is an indication of the conclusive step. So we have to convert out of 3 ones any 2 ones into 0. So we can try for these two. This is C2. Prepare one formula for C2. C2 is C2 minus C1 and C3 is C3 minus C1. With respect to C1, we can make it these two 0. Applying these two properties on the determinant, and delta equal to x, y, z. No change in C1, 1 x, x square. And C2 is C2 minus C1, 0, y minus x, y square minus x square, and 1 minus 1, 0, z minus x, z square minus x square. Okay. Now, from C1, we can take x minus y common factor because of cyclic order, x, y. From C2, z minus x can be taken. So, taking out x minus y from C2 and z minus x from C3. Now delta is x, y, z, the factor x minus y, another factor z minus x. Then 1 x, x square, first column. Then 0 minus 1, 0 minus 1, here y minus x and y plus x, so minus of x plus y. Okay, and 0 x minus z is common factor is taken out, so 1 z plus x. There are 2 zeros in R1, so expanding along R1 and delta equal to x, y, z, x minus y, z minus x into the 1 into cofactor, that is a11 alone. Then delta equal to x, y, z, x minus y, z minus x. What is a11? minus 1, 1 minus of x plus y, then z plus x. Then delta equal to x, y, z, x minus y, z minus x into minus z minus x plus y. So minus x and plus x cancel. This y minus z. So therefore, what is delta? The given determinant. It is x, y, z, x square, y square, z square, x cube, y cube, z cube equal to x, y, z, x minus y. From here, y minus z into z minus x. Okay. Hence the proof using properties of determinant. Go through it. The next question, the determinant 1, 1, 1, A, B, C, A cube, B cube, C cube is product of 4 factors, B minus C, C minus A minus B and A plus B plus C using properties of determinant. So dear student, minimum 3 properties should be used before expansion. Just remember the concept. So before expanding the determinant, at least 3 properties should be used. Okay, so we will start as usual. Delta is the given determinant. 1, 1, 1, A, B, C, A cube, B cube, C cube. We will try to make these two ones 0. So let us write formula for C2. C2 is C2 minus, so C2 minus C1 and C3 is C3 minus C1 with respect to C1. Then delta equal to 1, 1 minus 1, 0, 1 minus 1, 0. A, B minus A, C minus A. And A cube, B cube minus A cube, C cube minus A cube. Okay. From C2, B minus A can be taken as a common factor. From C3, C minus A is common factor. Or taking out B minus A from C2 and C minus A from C3. Okay. Then delta is B minus A is common factor and C minus A another common factor. Then 1 A cube, 0 here 1, other than B minus A, B square plus AB plus A square. Then 0 1, other than C minus A, C square plus AC plus A square. Okay. Now we can expand along. There are 2 zeros in R1, so expand along R1. Then delta expanding along R1. Delta equal to B minus A into C minus A into A11 into 1, A11. Then delta equal to B minus A into C minus A, A11, just cross multiplication of these 4 terms, 1 into C square plus AC plus A square, subtract this product, minus B square minus AB minus A square. Okay. Then plus A square minus A square cancel. Then delta equal to B minus A, C minus A. Then C square minus B square, C minus B into C plus B. These two. Then AC, AB mean A common plus A into C minus B. Okay. here c minus b common factor, take it out. Now delta equal to b minus a, c minus a, then c minus b, then a plus b plus c. Okay. What is delta? Delta is a given determinant. So therefore delta 1 1 1 a b c, a cube b cube c cube. So look at here, b minus a not in cyclic order, c minus a in cyclic order, but c minus b in reverse order. If we rearrange these two, minus or minus plus will come. Now we can write all factors in cyclic order, a minus b, b minus c, c minus a, and then a plus b plus c. This is the required result. Answer bro. Let's go through it. We will discuss one more problem. So dear student, in the third question, y minus z, z minus x, x minus y, and xy plus yz plus zx. So all are in cyclic order. So this is the determinant. Now we can start. So delta is the given determinant. X square, yz, and y square, zx, z square, xy. Okay, just look at the C3, yz, and the x factor is left out, zx, the y factor is left out, xy, then the z factor is left out. So we can do one thing, multiply r1 by x, r2 by y, r3 by z. At the same time, we have divide outside, multiply and divide. So we can write multiplying by r1, r2, r3 respectively by r1 by x, r2 by y, and r3 by z. Okay, then delta equal to, inside multiplication and outside a division. So 1 by xyz, then x, now x square, x cube, xyz, y square, y cube, xyz, z square, z cube, xyz. Okay. Now the xyz can be taken out of the determinant as a common factor. So taking out x, y, z from C3, then delta equal to, straight away, x square, x cube 1, y square, y cube 1, z square, z cube 1. Or rearranging without affecting the cyclic order, we can bring 1 to C1, and so x square, x cube 1 means next to 1, x square, 1, x square, x cube. The same thing can be written without affecting cyclic order, delta equal to minus 1 square. Yes, 2 times we are rearranging, 1 x square, x cube, 1 y square, y cube, 1 z square, z cube. Similarly, to make it these two 1 0, write a formula. R2 is R2 minus R1 and R3 is R3 minus R1. So minus 1 square positive, delta equal to 1 x square, x cube, and 0 y square minus x square, y cube minus x cube, 0 z square minus x square, z cube minus x cube. Okay. Now y minus x common factor from R2, z minus x is common factor from R3. Taking out y minus x from R2, z minus x from R3, then delta equal to y minus x into z minus x into 1 0 0 x square, other than y minus x, y plus x, uh, here z plus x, then x cube, then other than y minus x, y square plus xy plus x square, other than z minus x, z square plus xz plus x square. Okay. Now there are two zeros in C1 expanding along C1, expanding along C1, you can get delta equal to y minus x, z minus x into a11, straight away y plus x into z square plus xz plus x square minus z plus x into y square plus xy plus x square. Okay. If we multiply and rearranging the terms after factorization, we can get delta equal to y minus x, z minus x, then x minus y into xy plus yz plus xz. So this is not in cyclic order. So we can, when we rearrange, x minus 1 negative factor, z minus x, so next to z, then one more inside also one negative factor will come. So rearranging, we can get x minus y. All factors will be in a cyclic order. Just expand and factorize, you will be getting x minus y, z minus x, x minus y, z minus x, and y minus z, or in x minus y, y minus z into z minus x, and then xy plus yz plus xz. The delta can be replaced by the given determinant. This will be the expecting result, the final result. Then we will meet in the next video session. Thank you, students.